What is the ratio of initial velocity to its initial acceleration? Whereas the value of displacement with respect to time of a particle is given in the question. It's known that the velocity can be calculated by deriving the it's known that velocity is nothing but rate of change of displacement. So here we have a value of displacement. So we can differentiate the displacement with respect to time. So we can write d over dt of alpha t power 4 plus beta t square plus gamma t plus del. So when we are differentiating, the velocity will be equal to alpha times 4t power 3 plus beta 2t plus gamma times 1. So again, we can rearrange this equation as 4 alpha t power 3 plus 2 beta t plus gamma. So this is an expression for the velocity. Let us calculate the acceleration. It's known that acceleration is nothing but rate of change of velocity. So here we can differentiate the velocity expression with respect to time. So when we are doing that, we will get the expression for acceleration. So when we are deriving, we will get 4 alpha times 3t square plus 2 beta times 1. Again, this is a constant, so it will be 0. So we will get 12 alpha t square plus 2 beta. So now we have an expression for acceleration and velocity. But here the question is regarding the initial velocity and initial acceleration. Initial velocity is nothing but when the time is 0. So let us apply t is equal 0 in the expression of v. So v will be equal to 4 alpha 0 power 3 plus 2 beta times 0 plus gamma. So based on that, we can write the initial velocity will be equal to gamma only. Similarly, the initial acceleration is representing when the time is 0. So here we can write the acceleration will be equal to 12 alpha times 0 square plus 2 beta. So the initial acceleration will be equal to 2 beta. So now we have a value of initial velocity and initial acceleration. So the ratio will be gamma is to 2 beta. So the correct answer for this question is option D here.